basically, you would have got here consists of 10 data points in a box plot for K and N at the best K. So the median was 26. We have an upper bound of 27% error rate and a lower bound of somewhere between 24 and 25%. However, you can see random forest is consistently outperforming K nearest neighbors to the best K with a median between 23 and 24%. And I don't even think that upper bound crosses this lower bound here. So random forest is doing quite well. So this is how we can, cross-validation allows us to really compare different machine learning methods side by side. So a lot of times you look at machine learning papers or statistics papers, they're using cross-validation results to show that their method outperforms or is competitive with other methods out there. And so when I submitted my paper, that's what it was. It was cross-validation box plots, just like this, but made in ggplot. Sorry, I know base is kind of ugly, but base is really good for making quick box plots. And so the last part is easy cross-validation with the carrot package. So we saw the carrot package being used for the confusion matrix, and now it's going to be used to make cross-validation a lot easier with a lot less lines of work. And so what we need to do for our cross-validation is first set up some quick details about the cross-validation we want to do. So in the carrot package, that belongs to the train control function. So train with a capital C for control, and all we do is we put in what things we want. So here we want a repeated CV, so that's what we had before. We want to repeat our cross-validation more than once, so this corresponds to repeated CV. We want a 5-fold cross-validation, and we want our repeats to be 10. So that's very simple to put in. If you wanted 10-fold cross-validation, you put number equals 10. If you wanted 100 repeats, you put repeats equals 100. So this repeats corresponds to the outer loop, and this number here corresponds to the inner loop. Then all you do is one line of code to fit your cross-validation loop is that you do, we're going to use the train function from carrot. So in this case, if I want to fit a K nearest neighbors using the carrot package, I use train, and I do here class tilde dot means use all the predictors in my data set. Data equals data, that's the data that we put in. Don't have to worry about separating out into training and testing, it does it all for you. We're using the K and N method, so automatically goes to using K and N, don't have to worry about any parameters for K and N. And here goes to the controls we put in before. So fit control were the telling it we wanted 5-fold cross-validation 10 times. Then you have a look at the object you get, and what it's done is that it's done a 5-fold cross-validation 10 times for you, and it's actually tested different values of K for you as well. So it's done all the hard work for you, and it gives you, so the accuracy is just 1 minus the cross-validation error. And so in this case, because they repeated it more than once, they found that actually K equals 9 is the best nearest neighbors, and it gives you an accuracy of 73.5%. So that was all in this many lines as compared to the horrific loop I showed you before. So why on earth did I do that? So that might be your face right now. So not every machine learning method is covered by the carrot package. It's the biggest thing. And so I mean, a lot of them are out there covered by carrot, K and N, lots of random forest, lots of obscure things are covered by carrot. But not everything under the sun is, and especially if the method's quite new, if you want to test it out straight away, probably won't be covered by carrot just yet. But if it is covered by carrot, it's so easy. All you do is specify, method equals K and N, and all the details for that function, it does all for you. You don't have to worry about all the back-end stuff. And I think that knowing how to code up the cross-validation loop by hand reinforces the mechanics of what's going on statistically behind the scenes. So if you just, if I just learned the carrot package in 3rd year, we would be actually appreciating that it goes through, splits it up, goes through each fold, and then gets an error, and then repeats this over and over again. So I never actually, because I did it by hand in 3rd year, I never forgot. So maybe that might, going through the hard stuff first makes the easier stuff a lot easier to appreciate later on. And so for me, But if you make your own machine learning method, you actually have to make your own. You can't use caret because you're the one making your own method. So I always make my own cross-validation loops. And this is a good skill to know how to have. But of course, if you're not making your own methods, the caret package will probably just do just fine. So if you were to actually do cross-validation for your work later on, I probably wouldn't be making for loops. I probably just use the caret package. And so the last task is just to repeat the KNN and random forest procedures but in the caret package and see how they compare to your manual cross-validation you did in for loops. And you can find specific specifications for caret here. So you might have to put some extra parameters in for different models. And here's a list of models that you can get using caret. So there's quite a lot of models. So I guess so the last task you can do is I'll just finish off like the talking bit right now. So thank you to Emmy, who's not here, for developing the slide deck I used today. Ihui made Jarangant all together. I guess thank you to RLadies and everyone for coming today. And I had a question said to me, which was, what should I do if I actually want to work in machine learning research? And what you should do is do maths. So it turns out that all the stuff to actually make a machine learning method is all mathematically based. So if you're really interested in building your own machine learning methods, mathematics, I wish I'd done more, even though I did half my degree in maths, I wish I'd done more. Having an intuition, so half of it you can't teach people. Pure mathematicians probably can't do some of the stuff we do because they have different intuitions for different things. And so you have to be really curious and persistent to work in machine learning and have just an idea of what the data is doing. And if you have an intuition and persistence that you always, the mathematics is a barrier that you'll get through. And you can't teach yourself. If you have good intuition, you have good curiosity and passion, that's all that matters sometimes as well. So that's my spiel, and then this is the last task.
Awesome. Thank you so much, Sarah. So they probably won't kick us out for another 15 minutes. If you want to hang around and do this, no problem.
This task's really easy. So
yeah. If you need to run away, we totally understand. Please leave your name tags with us. We will bring them next time so that you will just have